At the very heart of our galaxy, there's something completely invisible. It doesn't shine, it doesn't glow. But it weighs millions of times more than our sun. Some of these cosmic mysteries are so massive, they outweigh billions of suns combined. These are the supermassive black holes, the silent giants that rule over entire galaxies. What exactly is a supermassive black hole? Well, most black holes, the kind we usually hear about, form when a giant star runs out of fuel and collapses under its own gravity. But supermassive black holes are a completely different beast. They are millions, or even billions, of times more massive than our sun. To give you a sense of scale, some of them are larger than our entire solar system. And here's the truly mind-bending part. Almost every large galaxy, including our very own Milky Way, has one of these behemoths lurking at its core. They are the gravitational anchors holding everything together. Imagine trying to find something that emits no light, hidden in the brightest, most crowded part of the galaxy. That's the challenge astronomers face. So, how do we know they're even there? Well, let's take a trip to the center of our own Milky Way galaxy. Here, we find a monster named Sagittarius A star. This supermassive black hole weighs about 4 million times as much as our sun. Of course, astronomers can't see it directly. It's a void. Instead, they do something clever. They watch the stars around it. They've observed stars whipping around a seemingly empty point in space at incredible speeds, moving so fast that only an object with the immense gravity of a supermassive black hole could possibly be holding them in orbit. It's like watching leaves swirl around an invisible drain. The motion of these stars, the smoking gun, the undeniable proof that a silent giant resides at our galactic center. But Sagittarius A star, as massive as it is far from the biggest one out there. Some supermassive black holes are so extreme they challenge our understanding of the universe. Take Ton 618, for example. This absolute colossus weighs in at over 60 billion times the mass of our sun. That's not a typo. 60 billion. Objects like this are so large that their event horizon, the point of no return, would stretch far beyond the orbit of Neptune in our solar system. The gravity they exert is so powerful that it doesn't just capture nearby stars. It shapes the structure and evolution of their entire host galaxies. These aren't just cosmic accidents or random occurrences. They are the central engines of the universe, fundamental components that dictate how galaxies are built and how they behave over billions of years. So, the big question is, how do they get so ridiculously massive? It's one of the hottest topics in astrophysics today. Scientists have a few leading theories. One idea is that they grow by merging with other black holes. When two galaxies collide, their central black holes spiral towards each other and eventually combine, creating an even larger one. Another way they grow is by continuously feeding. They are constantly pulling in and consuming vast amounts of gas, dust, and any unfortunate stars that wander too close. They grow alongside their host galaxies in a sort of cosmic partnership. But there's a puzzle. In the early universe, we see supermassive black holes that are already enormous, meaning they must have grown shockingly fast. How they manage this so soon after the Big Bang is a profound mystery that scientists are still working hard to solve. Now here's where things get even more fascinating. The relationship between a supermassive black hole and its galaxy is deeply connected. They grow together in a delicate, cosmic dance. It's not just the galaxy feeding the black hole. The black hole also influences the galaxy. When a black hole becomes too active, feeding on a huge amount of material, it can blast out immense jets of energy and radiation from its poles. These jets are so powerful they can travel across the entire galaxy, heating up the surrounding gas and blowing it away. This process can effectively shut down star formation in the galaxy because stars need cold gas to form. So, in a strange and counterintuitive way, these cosmic monsters act as regulators, helping to control the growth and life cycle of the very galaxies they inhabit. What would it be like to get close to one of these giants? The laws of physics, as we know them, begin to break down in extreme ways. As you approach, time itself would begin to slow down for you relative to a distant observer. Gravity becomes so intense that it twists the very fabric of space. Stars that get too close are stretched and torn apart by the immense tidal forces in a process gruesomely called spaghettification. The material from these shredded stars forms a glowing, superheated accretion disk around the black hole, which can shine brighter than all the billions of stars in its galaxy combined, creating what we call a quasar. Yet, for all this chaos at the center, life just a few thousand light-years away can exist peacefully. Our own solar system is a perfect example, orbiting our galaxy's monster from a safe and quiet distance. So, why does any of this matter? Why do we spend so much time and effort studying these invisible giants? Because supermassive black holes are fundamental to understanding the universe on the grandest scale. They help explain how galaxies form and evolve over cosmic time. They provide a natural laboratory for testing the limits of Einstein's theory of gravity and our understanding of space-time. Studying them pushes the boundaries of physics, forcing us to confront concepts like singularities and event horizons. Simply put, without supermassive black holes, the universe as we know it would look entirely different. The galaxies, the stars, and perhaps even the conditions necessary for life might not exist in the way they do today. They are a key piece of the cosmic puzzle. These giants are silent, they are invisible. Yet, they are unimaginably powerful. We often think of black holes as cosmic vacuum cleaners, pure agents of destruction. But the truth is far more complex and beautiful. Supermassive black holes are not the destroyers of the universe. In many ways, they are its architects. They are the gravitational heartbeats that shape the galaxies around them, regulating their growth and sculpting their destinies. At the center of nearly every galaxy, a dark giant waits, not just as an ending, but as a fundamental part of the cosmic story. Thank you for watching. If you found this journey into the dark heart of galaxies as amazing as I did, don't forget to like, subscribe, and hit the bell for more explorations of our incredible universe.